Section 4.4 touches on the vertex form of the parabola, and we're going to do part 1, which is graphing using symmetry. So let's recall. Describe the following properties of the parabola with this equation right here. So our vertex can be picked out from these two positions here. So this is 4, 3. So that's our vertex, okay? 4, 3, and our axis of symmetry is just this x. Oh, I put y. It's just this x value here, 4, x equals 4. Okay, just as a recall. Now, let's sketch this graph using the table of values. So if you're given a table and it doesn't have any x coordinates in it, what we want to do is we want to take this 4, 3, and we want to put it right into the middle, okay? So 4, 3. What this is going to allow us to do is it's going to allow us to have the maximum or the minimum in this graph, okay? So sometimes what happens is a lot of students just choose maybe numbers 0 to 5. I'm just making this up. And what happens is maybe the parabola is over here and then opens like this. So what happens is when you choose bad numbers, let's call them bad numbers. Maybe you chose 0 to 5. Okay? In this parabola, if we're only looking at this swing of it, this little arm of it, it's not going to look like a parabola. However, by putting the 4, 3 in the middle, what's going to happen is we're going to ensure that we have a window such as, and I'm going to box this, such as this right here, where it actually looks like a parabola because we can see either the maximum or the minimum. Okay, what we want to do is we want to go down to, so let's go 4, and then let's go 3 and 2, and then 4, 5, and 6. Okay, and let's go ahead and plug in the numbers. Okay, and I'm going to do this fairly quickly because the point of this lesson is not to teach you how to sub in numbers and graph parabolas. The point of this lesson is to really work with the vertex form. Okay, so we're going to have 2 times 2 minus 4 squared minus 3, we get 5. Then we sub in 3, we get negative 1. And my mistake here. There's actually negative 3. The h value is negative 3. Okay, if we sub in 5 and then 6. Okay, by putting the vertex in the middle and by going up 1, down 1, and then up another 1 and down another 1, what we're going to find is we're going to get the same answers right here. So we're going to, because we're focusing right here in on the 4, 3, the vertex, what's going to happen is we're going to have symmetry. So let's graph 4, negative 3, 5, negative 1, and then 3, negative 1, and then 2, 5, and 6, 5. And that right there is our parabola. Okay, and we can write in y equals 2x minus 2 squared minus 3. Or x minus 4 squared minus 3. All right, so now let's describe the set of values that x may take. So what values can we actually sub into this? Well, we can sub in any number. So let's start with any number, and then in one of the future lessons, we're going to go over actual domain and range, and we're going to find out what that means. And the last question, what numbers can y take? So, and I'm just going to add this here because it's just underneath. So the y value. If you think about it, the smallest y value is going to be this negative 3. And every single y value is going to be above that 3. So as long as y is greater than or equal to 3, it's going to be graphed. So those are the numbers that y can take on. Any number equal to or greater than 3. So here's a little note. This right here is the vertex form of the parabola, okay? And we've been exposed to this already now. Okay, this equation has a built-in negative sign, so I want to highlight this right here. So when we're given the vertex -5, 3, what we actually do is we sub in that -5 and 3. So right here for this h, we sub in -5, but it also has that built-in negative sign. So this is going to simplify, the double negative is going to simplify to a positive. It's going to look positive. However, the h value itself is negative. So let's do a little activity just to warm up. Write each equation in vertex form, unless it is in vertex form. Then what we're going to do is we're going to see the vertex, the axis of symmetry, direction of opening, and then whether it's stretched or compressed. Okay, so in vertex form, we can rewrite this as y equals 3 x plus 0 squared. Because see this, there's nothing in the bracket with the x. So it's x plus 0. And then of course over here, there's nothing, like it doesn't move up or down. So the vertex is going to be 0, 0. The axis of symmetry is of course that x value. And this is going to open up because the 3 is positive. Is it stretched or compressed? Yes, it's stretched. Let's put S by 3. Okay, let's go on to the second one. Y equals, and we're going to have -5, bracket. There's nothing here beside the x, so we can do x plus 0 again. Squared. So again, our vertex is 0, 0, and our axis of symmetry is the x value of the vertex. This one's going to open down. Okay, this is stretched by 5. So the negative sign allows us to know that the direction of opening is down, and then it's stretched by 5, and that's what the 5 stands for as a review. Okay, vertex form, y equals, I'm actually just going to put equals 1/2. We're going to have another x plus 0 squared, but this time we have a plus 3. So this time our vertex is going to be 0, 3. So x equals 0, because it's the x value of the vertex, and this one's going to open up. It's compressed by 2, or you can say by 1/2. Okay, so this one, let's rewrite -7/3 x plus 0 minus 2. So this time the vertex is 0, -2, and x equals 0, again, is the axis of symmetry. This one's going to open down because that leading coefficient is negative. It's -7/3. Now, some people think, oh, 7/3, that's a fraction. It's compressed. But if you do 7/3, it's actually 2 1/3. So 2, like the number 2, is actually a stretch. Okay? So for the rest of these, we don't have to put into vertex form. It's already in vertex form. So we just have to point out what the vertex is. So remember, if it looks negative, it's actually positive for the h value. So we have 4, 2. X is 4, that's the axis of symmetry. This one's going to open up because the leading coefficient here is just +1. And there's no stretch or compression. So we can say neither. There's no stretch or compression because this leading coefficient is still just 1. Okay, this time we get -1, 4. Okay, x equals -1. Now, this is going to open down because this leading coefficient is negative, and it's going to be a stretch by 2. Okay, vertex -9, -0.5. And x equals -9, and this is going to open up. And this is a compression by, and we can say 5/6. Okay, last one, vertex is -1, 4. Okay, then the axis of symmetry is -1, this is going to open down, and there's a stretch by 2 because that leading coefficient is both negative and the number 2. Okay, now we're going to get into the real lesson, graphing parabolas using symmetry. Okay, so parabolas are symmetric about the axis of symmetry, which is x equals h. Okay, so the axis of symmetry, what it is it's the midpoint between the two x values. So any two x values that are on the same horizontal. So what we would do is, like, for example, in this diagram below, we have x1, y1, so that's from point 1, and directly across, so on the same horizontal, we have x2, y2. Okay, and this is actually like x subscript 2, and then comma x subscript 1, or sorry, y subscript 1. It's just on the software, it didn't. Y subscript 2. On the software, it didn't allow us to put the subscript. So, what we would do is we would add the two x values. So where's this x to the left and where's the x to the right? And we can average them out and find the axis of symmetry, x equals h. So here's a note. For each value of y that is defined on our parabola, there's always going to be two values of x, okay, except for the vertex. So, i.e., what this means is that two values of x lay on each horizontal. So I'll highlight another one. So this one and this one. These ones are going to be the same distance away from the axis of symmetry, okay? This one here and this one here. So if we're subbing in like that x equals whatever it is, we're going to always come up with those, not for each x, for each y, we're going to have two values of x that lay on that horizontal. Okay, so each x, so for example, x1 and x2 are equidistant from the axis of symmetry. Now, how do we graph this? So first what we're going to do is we're going to graph the vertex, okay? And this is all about graphing now. So we're going to graph the vertex first, and then what we're going to do is we're going to choose a point 2 units to the left of the axis of symmetry and 2 units to the right of the axis of symmetry. Okay, and we're going to graph these values. And I believe this should be negative, this should be positive. Okay, the point 2 units to the right and 2 units to the left of the axis of symmetry will have the same y value. So this is a good check. What I do is, like, I always punch both of them into the calculator and just make sure. And then what we're going to do is just connect it with a parabola. So let's go ahead and do that. Okay, we're going to start with sketching the graph of y equals 4x squared. So in this, the vertex is going to be 0, 0. If you need to write this in vertex form, we can put x plus 0 or minus 0, and then we can see the 0, 0, but in this case, I'm just going to leave it, okay? So the axis of symmetry is actually going to be x equals 0. So now 2 points to the left is going to be 0 minus 2, which is going to be negative 2, and 2 points to the right is going to be 0 plus 2, which is actually just going to be 2. So what we're going to do is we're going to go ahead and sub in y equals 4, negative 2 squared. Okay, negative 2 squared is 4, I get 16. And we're going to sub in 2 squared. 2 squared is 4, and I get 16. So we have the point negative 2 comma, let's put this in another color. Negative 2 comma 16. We have 2 comma 16. And we have 0 comma 0. Okay. And all we do is connect these three, knowing that these 2 points here at 2 comma 16, negative 2 comma 16 are obviously higher than the vertex, so we know that it's going to open up. Also, this leading coefficient is positive, so we know it's going to open up. And we just label the graph. Sketch the graph of y equals 3x minus 1 squared using symmetry. Okay, the vertex is 1, 0, so the axis of symmetry is 1. 2 points to the left, so we use the 1 and then we subtract 2. So 2 points to the left is going to be -1, and 2 points to the right is going to be 3. So let's sub in y equals 3, -1 minus 1 squared. That's going to be -2 squared, which is going to be 4. So I get 12. We should get the same thing because we're using symmetry for the 0.2 units to the right. So 3 minus 1 squared, that's 2 squared, which is 4. 4 times 3 is 12. So these are the 3 points that we have. We have 1, 0, we have -1, 12, and we have 3, 12. Once we plot those 3 points, we know it opens up, so that's just a good check. And there's our parabola. Y equals 3, x minus 1 squared, and that's it. All right, now let's sketch this graph using symmetry. So taking a look at this equation right here, our vertex is going to be -4, -3. Our axis of symmetry is going to be -4, so 2 points to the left is going to be -6, and 2 points to the right is going to be -2. Now if we were to plug this in, y equals -2, -6 plus 4 squared minus 3. -6 plus 4 is -2 squared is 4. Minus 3, that's -8, -9, 10, 11. Okay, I'm actually going to just solve it for the 1 because this one you can go ahead and just double check, but it should be symmetric. So we get the point -6, -11, and we get the point -2, -2, -11. So -2, -11, -6, -11, and we get -4, -3. And we draw a parabola. We know it opens down because that leading coefficient is -2, and we can just label the graph. Y equals -2, x plus 4 squared minus 3. Okay, last one for sketching using symmetry. So this is the equation right here. We're going to pick out the vertex, which is 6, 4. Remember, this h value is always like opposite of what it looks like. So 6, 4, the axis of symmetry is x equals 6. So we want to go 2 points to the left, which is 4, and we want to go 2 points to the right, so we add 2, and this is 8. So we have y equals -1/2. Let's go 4 minus 6 squared plus 4. 4 minus 6, -2. -2 squared is 4. So now we have -1/2 times 4, and then plus 4. So 1/2 of 4 is 2. So we have -2 plus 4. Don't know why I put a bracket there. And we get 2. So our points are 6, 4, which is our vertex. And we're going to have 4, 2. And if you checked with the 8, we should also get 8, 2. And this makes sense because it's like kind of like short and fat because it's a compression by 1/2. And then we just label this. Y equals -1/2, x minus 6 squared plus 4. Okay, so if the following 2 points are on the parabola, state the axis of symmetry. So -5, 8, and 4 and 8. Okay, so if we have -5, 8, let's just plot it here, 4, 8. We know that both of these lie on the same horizontal. So it doesn't matter if the graph opens up, like so, or if the graph opens down, like so, and goes through those 2 points. All that matters is that they lay on the same y. Okay, so all we have to do is average out the x's. So just like the midpoint, -5 plus 4 divided by 2, I get -1/2. And that's the axis of symmetry. Okay, we can recognize that these y coordinates are both 4, so all we have to do is average out 2 plus 6. 6, 7, 8. 8 divided by 2 equals 4. So x equals 4 is our axis of symmetry. Now, it doesn't matter where we take these numbers from. So -1.5, kind of ugly, but as long as we lay on the same horizontal, we can just simply average out the x's. 7 plus 1 divided by 2, which is 8 over 2. Again, we get 4. So x equals 4 is this one's axis of symmetry as well.